Now, number 1 was so much fun, we have to do number 2. So here's number 2. And now I say that it's 210 meters long. But look at the angle now. 130 degrees. It's not a, well, how do we handle that? This is a little different than the first worksheet we did. So, here's what's given. So our R is 210 meters. Now this angle here is given to be, oh, I'll just put theta equals 130 degrees. So first let's draw the picture. Well, what are we trying to find? We're trying to find Rx and Ry. Let's solve. Now the first thing I'm going to do is draw the components. Here's Rx, and here's Ry. Now, when you draw components of a vector, always draw them as dashed lines. And when we get to force diagrams, free body diagrams, in a couple of units, that's going to be really important. But you just want to show, hey, here's my vector. Here are the components of that vector. The x and y components, or the vectors that make up the vector. So let's solve. Now we said that Rx is equal to R cosine theta. Now here's what students always do. They always say, well, let's see, this is 130, so this has to be 50, right? To get all the way to 180 degrees. And if you know what you're doing, you can do that. But let's put in the R, okay, 210 meters, times the cosine of 50 degrees. And let's see what R and the x is equal to.
Plus? Is it plus?
Well, yeah, is it, the question was, is it plus? And there's the rub, see? Okay, 210 times the cosine of 50 degrees. Okay, you probably can't see that. There it is. Enter. Now we get 134.98. We'll just call that 135. Is that right? No. Not really. What is right? Physics? Did you say somebody? Yeah. Well, let's just trust it. Let's do this. Rx equals R cosine theta equals 210 meters. But in polar coordinates, this is 130 degrees from the positive x-axis. That's the polar coordinate angle. So trust it. Just put in cosine of 130 degrees. So I'm going to plug that in now. 210 times the cosine of 130 degrees. And I get, if I round it off, I get negative 135 meters. Which one's right? This one's right. Now why is this right? Look what direction the component's in. R and the x is going to the left, not to the right. To the left is different than to the right. Yeah, what song is that? To the left, to the left. I don't know. I'll try not to do that again. So this is the x component. You see, if you use 130 degrees, it gives you the negative sign that you should have. Now, if you use 50 degrees and you go, oh, but wait, look at my picture. It's actually to the left, and just stick the negative in. Okay, you know what you're doing. But if you just stick with the angle as it's given, you'll be fine. You won't have to think. You won't have to look at the picture. It'll give you the component, the correct component right away. Does that make sense to everybody? All right, so let's do r in the y equals r sine theta. And so that's 210 meters times the sine of, well, let's use 130 degrees. So let me clear it. See, 210 times the sine of 130 degrees. And my calculator says it's 161. You round it off. Meters. Don't forget the units. Now, does that make sense? Should it be positive? Yes, it should be positive, because look at my picture. R and the y is upward, and we say that up is positive y. Well, you say, wait a minute. What if I use 50 degrees? Well, guess what happens when you go 210 times the sine of 100, oh, not 100, shoot. 50 degrees. You get the same answer. Because you may have learned in AM or AMA that the sine of supplementary angles are equal. The cosine of supplementary angles are opposite. Okay. So, so there you go. That'll help you in there. Okay? And because look, in order to go, here's where you're starting. In order to get up here, you have to go to the left and then up. To the left and then positive is up. Okay? You are making a right triangle out of it, but now, you're moving to the left from where you started. Instead of, like in problem 1, we moved to the right. So it was a positive component. Yes? Yes? Do you all see it? I think they all see it. That is all.